Hi, my name is Dr. Ahmath. In this video lecture, we are going to discuss about increasing and decreasing regions of functions and how to identify them. So first of all, I would like to start this lecture with the definition of the tangent line and what does it mean physically. So the tangent line is the line which is touching the curve at some point, and the slope of this tangent line can be found by taking the derivative of this function at that particular point. So the slope of the lines are very important, and in order to give you some impression about what does it mean, the slope, and how the changing the values of the slope of the line is going to change the line, the picture of the line, I'm going to show you a couple of examples. So for example, this line is going to have the slope to be equal to 1. And if I would write down the equation of this line, I would do this like y is equal to the x plus 0. Okay, so as I will just rotate this curve, rotate this line, the slope is going to be changed. So if I rotate this curve towards the y-axis, the slope is going to increase. So it is going to be equal to the 2, for example. And if I rotate this towards the x-axis, it is going to be equal to the 0.5. It's going to decrease. So when the line becomes simply horizontal, like any horizontal line here, or here, or here, all of these lines have the slope to be equal to the 0. Okay? So as I rotate this towards the y, the slope is going to increase. As I rotate this, the line towards the x, the slope is going to decrease, and eventually it's going to reach the 0. So at the same time, if I just keep rotating this line and go into the different direction, the slope can be negative. So I use one method to memorize what is the positive slope or what is the negative slope. So if you can put your right hand on the top of the line, then the slope is a negative number. And if you can put your left hand on the top of the line, then the slope is positive. So in this case, I can put my right hand on the top of this line, so that's why the slope is equal to the -1. But the same rule works as previous. If I just rotate this curve towards the y, so the absolute value of the slope is going to increase. And if I rotate this curve towards the x, the absolute value is going to decrease. Okay, for example, this line has the slope to be equal to the 0.5 negative. So what I want to do is I would like to use the slopes, the tangent lines, in order to identify the increasing and decreasing regions of functions. But first, I would like to define what does it mean actually, increasing function or decreasing function. Well, the function is called increasing in some region A and B if for any two values on the x-axis, x1 and x2, so that x1 is smaller than x2, the values of the functions are also going to be in the same order. So the f of x1 is going to be smaller than f of x2. So let me sketch this in order to explain you. So I'm going to choose 2 points, x1 and x2. So they can be any 2 points in this interval. The only constraint is that x1 should be smaller than x2. But now, if I just go and define what is the height of the function at the x1 and at the x2. So what do you think? Where the height is higher? So obviously at the x2, the height is higher. So essentially f of x2. So this point is x1 and f of x1. This point is x2 and f of x2. So f of x2 is bigger than f of x1, right? So this is what does it mean increasing function by definition. And it should work for any 2 points, okay? So similarly, the function is called decreasing if for any 2 points from this interval, x1 and x2, where x1 is smaller than x2, f of x1 is bigger than f of x2. So essentially, I can choose any 2 points, for example, here x1, so here I can choose the x2. So if I find a height of the function, so let me just put this height here. If I find the height of the function here and here, f of x1 is going to be bigger than f of x2. So essentially, this is the height, right? This is the height of the function. So this is what is called the decreasing function. So this is the definition of the increasing and decreasing function, and what we want is we would like to build a tool which helps us to identify where the function is increasing, where the function is decreasing. Well, I drew the parabola, simple parabola, the quadratic function y is equal to x in the square. What I want to show you is that you can identify the increasing regions using the slopes of the tangent lines. So here I've got the function y is equal to the x in the square. So you can see here on the positive side of the x, I can put the slope of the tangent line, or I can just draw the tangent line. The slope of this tangent line is positive. As we discussed before, you can put your left hand on the top of this tangent line. And as you are going to change the points and draw other tangent lines, for all of these points, the slope of the tangent line is always positive. Okay, so it means that the slopes are positive. Slope of tangent lines are positive if function is increasing, right? It means that derivative of the function at any point where the function is increasing, right, is positive. Okay, so this will be some insights how we can identify increasing regions. So, well, if I look to the decreasing regions, I can see here that the slope of this tangent line is negative because I can put my right hand on the top of this tangent line, and I can choose any other point from the decreasing region, and I can see that the slope of the tangent line is negative. So essentially the slopes are negative in decreasing regions. Slopes are negative in decreasing regions. So the slope of the tangent line, if you remember, it's a derivative of the function, right? So that is why f prime of x is smaller than 0 in decreasing regions. So we can just quickly check this for this function, because this function is y is equal to the x in the square. Derivative of this function is equal to the 2x, right? And it's clear that this derivative is positive. For x is more than 0, it's positive. And for x is less than 0, it's negative. Okay? So you see, so if x is more than 0, then the function is increasing. If x is less than 0, the function is decreasing. So let's do a small exercise in order to find the increasing and decreasing regions of the following function. So let's say we are given the function x in the power 4 minus 4x cubed. We need to find its increasing and decreasing regions. And the way how we are going to do this is in the following way. So we first of all find the derivative of this function. F prime of x is going to be 4x in the cube minus 12x in the square. I'm going to factorize this. I'm going to take out the x in the square from the brackets, or I can do this 4x in the square, right? So if you do this, what is left is x minus 3. Okay, so I factorize this, and what I have to do is I need to find the signs of this function of the f prime of x. So what does it mean? So I need to draw the number line. So it is going to be the number line x. I need to put the zeros of this function, first of all, right? So where f prime of x becomes 0, it is becoming 0 at the point 0, right? At the x is equal to the 0. And at the point 3, x is equal to the 3. So what I have to do is I need to just like split this into the 3 intervals, because in these 3 intervals, the sign of the f prime of x might be changed. And I need to identify the signs. So if I choose any number bigger than 3 and substitute this to here, for example, if you choose x to be equal to the 4, right? So the f prime of 4 is going to be some positive number. It's going to be positive. And if you choose some number less than 3, for example, 2, then this is going to be negative, because if you substitute the 2 to here, it's going to be positive number. If you substitute the 2 to here, it's going to be negative number. Positive times is negative. It is going to be negative. And if you choose any number which is smaller than 0, it's still going to be a negative, right? Because here, if you choose some negative number, so let's say minus 1, what is the f prime of minus 1. It's going to be 4 times the minus 1 in the square times the minus 1 minus 3, which is a negative number, right? It's still going to be negative. So please note that the signs didn't change around the 0 because of this x in the square. Well, what we've got is we've got the signs of the derivative of the function, which tells us where the function is increasing, where the function is decreasing. It tells us that the function is decreasing all the way down from the minus infinity until 3, and it's increasing all the way up from the 3 until plus infinity. I'm going to show you the graph of this function here, and you can see here that the function is decreasing from minus infinity until 3. Then after 3, the function starts increasing. So this is how we can identify increasing and decreasing regions, and it's really important for us because in our next video lecture, we're going to discuss about how to find the maximum and minimum values, and it appears that it's very important for us to understand where the function is increasing and decreasing in order to identify the points, whether they are the maximum points or the minimum points. Well, thank you very much for your attention. I hope that this was helpful for you.